Okay, we're gonna bring back our table of contents. All right. So now we're going to add realistic preset trees using a table of trees genus type. ArcGIS Pro provides preset layers for displaying features in a 3D map. So now if we have a field with the genus or general type of trees, for example, pine or pinus, we can display multiple trees by the type. And on the map tab, we will go to layer group, map tab. All right, and layer group is right here. And we will add a preset realistic trees, Cool. And then we will go to our chapter folders, chapter 11 tutorials and chapter 11 geo database, and select street trees and click OK. And then the symbology pane under the type. So we will do is that we will click the genus name and height. We don't have to do anything, and then we can close the table and use the streets bookmark. And trees are draped to various elevations and display using the tree genus type. And we will zoom out the map to see more street trees. Cool. Okay, and then we can save the project. And we will do another fun one. So using the Lidar, we will create features and line of sight analysis using the Lidar data. So Lidar uses pulsed laser light from aircraft or drones to provide detailed elevation data and classification of land cover that we can use to create 2D surfaces and 3D features. Geographic Lidar data is commonly available as Lidar area survey files, the industry standard of the American Society of Photogeometry and Remote Sensing. So Lidar files were provided by the Pictometry International Corporation for a study area of Algonac County, Pennsylvania. So the generation of 3D buildings from Lidar LAS data sets require two surface models. So the digital surface model, and digital terrain model. So DSM and DTM, they are then used to create a normalized and DSM surface, which is the difference between the DSM and DTM surfaces used to calculate building heights. The normalized surface and DSM is applied to random points that are created for 2D building footprints. These footprints are used to generate z-values heights for each random point. The z-value of the highest point is the building height. The process finishes by creating a statistic table that selects the maximum z-value of the random points that is joined to 2D building footprints, allowing for buildings to be extruded using that value. The Lidar data can also be used to determine line of sight obstruction between features, such as building as seen in the last exercise that we did. And now we had the 10.4 open. Oh, this is 10.3. I'm gonna close it out and open the other one. This is for the trees. Close it out. Alright, so now we will use the Lidar data, okay? So create features and line of sight analysis using Lidar data. So create features and line of sight analysis, line of sight. So The project opens with the 3D scene and the building footprints displayed as a 2D layer and the world light gray base map in a local view, with 2D layers for buildings and light delivery area used to clip the base map. There is no height value in the building attribute table, so buildings can be displayed only as flat 2D polygons for now. Additional layers of observer points used for line of sight analysis and a 3D layer for bridges are turned off. So then we will use the 3D view bookmark. So bookmark, 3D view, perfect. And then we will use an LAS Lidar area survey. Lidar area survey. File have a points classified as bare, earth, vegetation, buildings, and so on, and are created from original large Lidar area survey American Standard Code for Information Interchange, or ACS Standard Code for Information Interchange file, which can then be viewed in 3D or made into raster data layers. So an LAD dataset created from original LAS data provides fast access to LiDAR data without the need for data conversion, making it easy to work with LAS files for a specific study area. And in the geoprocessing pane, we search for and open the Create LAS data tool under Input File. So we have to go to geoprocessing pane first, and then for tools, we will have to search for Create LAS data set. I really like this tutorial because I haven't got to use those tools before, and it's a lot of tools. Never get to use a lot of tools, but this book let me use a lot of chances. So now I'm gonna do is we have a 6 LiDAR. It's not in chapter 9, so it will be chapter 11. And in our tutorial, then it will be data. So our data, LASD, so data, not in this folder, LAS. Okay, that's the 6 files. So let's see if it opens. Okay, perfect. Now it opens Flash, and then the output data set, and we will put, I will not use this weird name. I will give a name, chapter 11 underscore, and then last dataset, and then LASD. Okay, perfect. For the coordinate system, we will change it into 1983, NID 1983, custom. I'm gonna go back again, stay plain. So US feet and Pennsylvania, stay plain, Pennsylvania. Scroll down, we will go to Pennsylvania South and click OK. And 3702, no LiDAR area survey. Okay, files, and click Run. So, and then we will close it after it finishes, and the LiDAR data values are clearly shown as raster points and their values. It's very beautiful, and the LAS dataset can be symbolized using elevation, slope, and aspects. Perfect. Okay, that's beautiful. Wow, look. And so on. And so on. So now, this is the LiDAR data that we use, and Pittsburgh's tallest building in the U.S. steel building and the triangular building on the right side of the study area. Cool. And we explore a little bit using the 3D view bookmark. This book really enjoy. All right. Okay, and then we will generate a raster digital surface model. Digital surface model. So the DSM represent the surface of the earth, including buildings and tree canopies and other obstructions. Before generating the DSM raster, we first filter LiDAR points to save the processing. We will create a DSM using an interpolation type of binning, which is faster for processing and a maximum cell assignment to find the highest elevation point within each cell. So for that, we will in the contents pane, we will click the chapter 11, this right here, and I'm gonna expand it a little bit, and last filter. So right click on this and go to LES set filters and go to last first points, all points. Okay, we don't have yet. So binning. So the binning. Okay. On the Appearance tab, we will click the Tool button and search for and open the LiDAR Areas Survey dataset to raster tool. Okay, so first return. It shouldn't be first return. It should be first point. Okay. Filter first return. Maybe it's not point. In this version. So in the old version, it's first point, but here the great upper version, it's first return. And let's click that. And then on the Appearance tab, right here, Appearance tab, we have to wait a little bit. And click the Tools. Appearance, click the Tools button and search for and open Appearance Tools. On the Appearance tab, click the Tools button and search for and open for, oh, this shouldn't be Appearance, then it will be the Analysis. Okay. Alright, we go back to Analysis and Tools. That we will say we will have to find the tool is LiDAR Area Survey Data Set to Raster, the conversion tool. And for the OSD, it's chapter 11. I will say this one will be saved in our chapter 11 database. This one will be DSM, which is Digital Surface Model, and Elevation binning maximum. This one will be maximum linear floating point and cell size, and we will run the tool, and we will turn the chapter 11 Landsat data LASD and blocks off. And the value of the data surface model shows the range of elevation from the high to low. And it created into kind of like a 2D now. Cool. Turn this off. Okay. And you can see the wider part, then you know which part is has the highest elevation. And we will create a raster digital terrain model. This one I did many times. So now we create the digital terrain model, a bare earth terrain surface containing only the topology. So in many cases, the DTM is the same as a digital elevation model. So digital elevation model, digital terrain model, digital elevation model. They are the same. Before creating raster, we will filter the ground features. So now we're going to turn this layer on. Chapter 11. This one is the LiDAR area survey data. And in the contents pane, we will right click on this data set and go to filters and then go to ground. filters, and ground. And this will filter and show only the ground feature you